Oh yeah, okay. So, today we're talking about the volume of a prism or a cylinder. Okay? And we're done. Good. Okay? So, the volume of a prism. I want you to cross this blank out. I left that in and should not have. So the volume of a prism is the area of the base multiplied by the height. Okay? The area of the base is signified by a capital B. The reason for that is because area is a square measurement, right? So there's two measurements that go into that B. So our formula in math parlance is volume equals B, big B, times H. Area of the base times the height. Okay? Make sure that the height comes from the perpendicular measure to the floor. Okay? It's like when you want to find out how tall you are, right? When they measure your height, you stand up straight, right? You don't measure your height like this. Okay? So your height is perpendicular from the ground up to the top. Okay? So, finding the volume of a prism. Let's look at the second one first, okay? I think that's a little easier. So what's our base? What's a base? It's the bottom, I agree. So on all prisms, you have two sides that are always going to be exactly the same, just opposing each other. Okay? So the base is going to be this triangle down here. Okay, you have one more base on there. What's the other one? The one above it, right? This one right here. So both of those are going to be your bases. When you're dealing with a prism or a cylinder, we'll get to cylinders in a little bit, but when you're dealing with either of these, you're always going to have two sides that are exactly opposite of each other, right? One's down here, one's up here. Those are going to be your bases. Okay? You see how those other three sides, they don't have a side that's exactly opposite from them, right? Okay? So, we want, our formula is area of the base times the height. Do we know how to find the area of a triangle? Yeah. I think so. What is it? 1/2 base times height. So the area of our triangle is 1/2 base times the height. Doesn't really matter which one we use where. We'll call 4 the base. So area of the triangle equals 1/2 of 4 times 3. So area of a triangle equals 2 times 3, which is 6. And that is our big B. So I can take big B out of the equation here, substitute in a 6. What's my height? How tall is that? 2, right? So I can take H out, plug in 2. So what's my volume here? 12. Okay? Units, what do you think our units are? Centimeters. Cubed. Okay? Centimeters cubed. You have 1 centimeter here, 1 centimeter here, 1 centimeter here. You got 3 of them, right? You're going to need centimeters cubed. Okay? The other way to know, the proper way to say that is you have a 3-dimensional figure, right? So centimeters, 3 dimensionals cubed. Okay, any questions on that? Find the area of the base, multiply by the height, you got the volume. Okay? Wake up. No problem. Put it away and don't do that again. All right. So, what's our base here? What shape is it? A trapezoid, right? Huh. It's weird that we did a trapezoid problem in the warm-up, huh? Okay. So, weird. Okay, so this trapezoid is our base, right? It's the sides that are exactly opposing each other. Okay. And up here as well. How can we find the area of that base? What do we have written down as the formula up there? 1/2. So area of a trapezoid equals 1/2 base 1, right? Which is, we can just call it 14, plus base 2, which is 6. Then times the height. So how deep is the trapezoid? Like how far through the wall is that figure going? Is that 3 or 5? 3, right? We're looking for the height of the trapezoid, not the height of the figure. So times 3. So our area of our trapezoid is going to be 14 plus 6 is 20. Divide by 2 is 10. Times 3 is 30. Okay, so 30 centimeters squared. So that's our big B, right? We know our big B now. Volume is always big B times H. We can take big B out. We can put in 30. Okay, what's our height of that figure? 5, right? That comes from this over here. So 30 times 5. Volume is going to be 150 centimeters cubed. Okay. Do you guys think that the way we first did that warm-up problem, where we found the area of the middle part and then the area of the 2 triangles, you think we could have done that again and we would have gotten the same answer? Yeah, it just would have taken us a little longer, right? Okay? So, it might be good to memorize those formulas. Okay? Alright, so we have prisms. Now we have cylinders. So the idea behind volume is it's always area of the base times the height. So if I have a base, you know, like that little like kid's toy where it's like the little donuts and like you stack them up that like cylinder thing, you know? So it's kind of like that. So the area of your base is like one donut thing, right? And then your height is going to be, let's just say you have 5 in the stack, that's 5. Okay, so how many donuts do you have on there? You have 5, right? Area of the base, 1 donut, times how many going up you have, which is 5. It's 5. Okay? So the area, the volume of a cylinder is still area of the base times the height. But we know how to find the area of the base when it's a cylinder, right? We know a better formula for that. What would that be? What's the base of a cylinder?
Circle.
Circle. Do we know how to find the area of a circle? Yeah. Pi r squared, exactly. So volume equals pi r squared h. Okay? Pi r squared h. What do we have? Do we have h on this first one to the left there? Yeah. Do we have r? Yeah, so we know how to find the volume, right? Volume equals pi. And then r is 9 times the height, which is 6. Okay, what do you guys get when you approximate that? What'd you get, Joey?
1,526.81.
Exactly right. Okay, feet cubed. Don't forget your units. Okay, 1,526.81 feet cubed. Okay. So if, let's just say that I'm that cylinder. Am I standing up straight right now? No, right? Okay, so make sure that you use this height. Don't try to find some height in there. That's not going to be right. Okay, so same formula, volume equals pi r squared h. What's our r? 4. And our height? 7. So volume equals?
At 351.86.
Perfect. Volume equals 351.86. What's our unit going to be? Centimeters cubed, exactly. All right. So, we want to use this stuff that we just learned, okay? So we're building a rectangular chest. You want the length to be 6 feet, the width to be 4 feet, and the volume to be 72 feet, okay? So we're missing the height, right? But if we know the formula is the same for all of them, right? Volume equals area of the base times the height. We know the volume. We want it to be 72 in the end, right? Do we know the area of our base? Yes. We could figure it out. What do you think it is? 24, right? Our base here is 6 by 4. Length times width. That equals 24. So our big B then, that's big B, is going to be 24 times h. How are we going to solve for h? Divide both sides by 24. So our height has to be 3. 3 feet cubed. Not cubed. Why not cubed? Because it's just the one measurement, right? We just want the one side. So it's just feet. Okay?
Can you go back up to that top problem over there?
Yep.
The one with the triangle? The triangular? Why is that not called a square prism? The one that's like a. Here's an example of it in real life. Why would you not call it square? It's got squares on it. Why don't you use the squares? Okay. That's the important part that you have to remember in real time. You know, when you think about a lot of your stuff is always drawn on 2-dimensional, but if you see it in 3-dimensional, you can obviously see that the bases is going to be the ones that have the two that are across from each other. So that's how you figure out which ones you're going to use in your base. Even though there are squares, they're not directly across from each other. So sometimes it's good to see it in like what it looks like in real life versus what it looks like on a drawing. Okay.
And it's the same idea here too,
Yeah.
right? Because you can't, like if you want a base, right, and it's round, you can't set that and
Right.
have it sit, right? It has to be sitting on the flat side, which are the two ends.
So when you get on like the ACT or one of those tests like that, they may draw it kind of weird, but if you can visualize it like this, it's easier for you to know which one to use.
All right. I want you guys to work this one with your partner that you're sitting next to, okay? So you're building a 6-foot tall dresser. You want the volume to be 36. What should the area of the base be? Okay?
Big B is probably 6.
And then like.
That's what I got.
Yeah.
Dylan, is that your dress or like you?
That wouldn't be my
Flowers on No. Oh, you have baby stuff. You want to gossip? There's dipsticks.
So that's your.
I don't have any stitches on the dress. Why not?
That's your possibility.
It's a thing about freaking 5.
I do.
I just got that dress like a year ago.
Oh. Yeah, you have the stickers on it. Yeah, dude. You know the Apple stickers that you go to? Oh, no, nothing.
She's not even there, so I was.
36. Got a boy?
And then you just use your package.
1.5 times 4.
Why do you put it out? Put it in the bottom right. Oh, yeah, there you go.
Well, then
Let me see.
the two numbers together.
So what are your possible ones in mind? So that's just your area type. So it goes on to ask what's the possibility. What are the possibilities?
You could do 1.90985.
What's the equation? 6, 1,
If
and 6 plus 6 times 6.
No, well, let's see, it says, so, you
And then
found
5
that
would be.
36.
what should be the area of the basement, so 6 feet squared, right? But then what are the possible answers for length and width? This is my.
2 and 2.5. Whatever.
What are my numbers that I would put on each one?
You have an IQ of what? Box of rocks. You have an IQ
What's
of
the
door.
easiest one to think about?
How'd you do it? Joey, how'd you do it?
I said 36 equals b times 6 because you don't know the base, but 6 is the height. And then you divide 36 by 6, which gives you 6 feet squared. And then one of the possibilities is 2 times 3, or 2 feet and 3 feet.
Awesome. 2 feet and 3 feet. Anybody have a different measurement? Paige, what'd you have?
1 and 6.
1 and 6. Anybody else? Abby?
12 and 0.5.
12 and 0.5. Anybody else? Will?
36 and 24 inches.
Okay, thank you. Okay, Braden?
4 and 1.5.
4 and 1.5, exactly. So the point here is, as long as the height stays the same and the volume stays the same, you can stretch and shrink that base however you want, okay, just as long as it stays proportional, okay? So there's multiple ways that you can get that volume, okay? It's like different size like cans and bottles, right, can have the same volume, right? It's still going to be like 12 ounces of pop. It's just, it's different size, okay? But it's still proportional. Okay? Any questions on what we did today?